In this video, we are going to take a look at the last type of pointers that we discussed, which are the void, the void pointers. The void here kind of has literal meaning like nothingness, right? But we'll talk about void pointer in a minute. Just like a quick recap, we talked about pointers as storing a number, and that number was that of a memory cell or a memory location essentially. And then we mentioned there are pointers that point to certain data types, right? Um, for example, int, char, some struct, something like so. And then there were pointers that pointed to functions. And then we mentioned there were pointers that were of the type void. And so we are going to now take a look at those. And again, these pointed to data, these pointed to code, right? And these pointed to code. Right. So now let's first talk about how you go about kind of declaring a void pointer or defining a void pointer. So let's say I have an integer I with a value 10. Then what I can do is I can simply say void followed by the usual asterisk with variable name and then say address of I. So in this case, like the declaration or definition of void pointers is same as that of data pointers, except instead of using like a data type here, you use the keyword void, right? That's the only difference in terms of how we define or declare them. Now, that said, pi is then pointing to a memory location where you have I stored, right? And I being an integer would be stored actually in 4 bytes, right? It would consume 4 bytes, and the starting byte is what pi will point to. And pi, of course, will be, some memory location where the address of I is saved, right? Now, so the first difference was in terms of declaration or definition, and the second one, which is the most fundamental one, is that you cannot dereference a void pointer. This has no meaning, right? In fact, the compiler will yell at us when we try to do this. It'll throw error. The question then is, what use are void pointers? And that we'll kind of cover in possibly 2 videos from now. And these are like extremely powerful. But the idea is that a void pointer simply holds the address and it cannot be dereferenced. That's the only thing that I want you to remember. And just as a teaser, a void pointer is useful in terms of extracting data out of a memory region or updating the memory region um, only when it is typecasted, right? And what typecasting mean, we'll also take a look at when we try and explore how void pointers can be used. For this video, just remember that the way to use or the way to define or declare a void pointer is by using the keyword void, and then the void pointers cannot be dereferenced on their own. That's the only thing. Now then, let's go ahead and take a look at an example. So what you see here is int I is equal to 10. So somewhere in memory, we have 4 bytes. So these are 4 bytes. Each one of this is a byte long, right? This is 1 byte, right? So somewhere here 10 is located. This happens to be I, and this here uh, is essentially where pi is pointing to. So let's say if it was hex 1, 2, 3, 4, then hex 1, 2, 3, 4 is what pi is pointing at, and pi is right here, right? So we have the void space star p star or asterisk pi equals to ampersand of I, which means load the address of I into pi as the variable. What we are doing here is printing the value of pi and the address of I just to confirm this fact, right? So let's just then go ahead. Let me get rid of this. Let's just go ahead and compile our code. And then after that, just a slash a dot out, sorry, dot slash a dot out to run our code. And if you notice here, this address, the number being printed here, is exactly the same as the number printed here. And that should hopefully confirm that P is indeed pointing to I by holding, or rather, this, and then uh, it is pointing to I by holding the address. And now let's go ahead and talk about the next thing, which is let's try and dereference this pointer variable. And so the way we dereference is we use asterisk pi in an attempt to go to the memory location that pi is pointing to, which is that of I, the first byte of I at least, and then we are trying to fetch contents from within it. And my claim is this will fail. And why this fails, let's take a look at that as well. So let's go ahead and try and compile, and it says error, invalid use of void expression. All right, now let's talk about why does the dereferencing fail. So note or recall that in case of pointers that were pointing to data types or the function pointers, in case of data types, the data type itself gave away the size or length of memory that should be dereferenced. So if we had like an int pointer, and when we dereferenced, in this case, an integer pointer, the fact that it's an integer pointer conveys that it must go ahead and read 4 bytes of memory in our case. Whereas when you talk about void pointer, the void keyword suggests nothingness. And in this case, what happens is star pi, the CPU or the compiler doesn't know how many bytes to go and fetch or manipulate. So the information about the size or the length of the memory that needs to be dereferenced, read or written to, that is absent because of the use of void as a keyword. And so what it does is it simply just points to the memory, but you cannot read or write simply by the dereference operation. In case of function pointers though, we knew that it's pointing to instruction, or at least that memory region would be considered as one instruction, and the program counter then just went ahead and kind of incrementally picked up instructions from the memory. The size of the instruction is fixed for a given machine, so how many bytes to read is also kind of conveyed or contained within the fact that a pointer is a function pointer. So long story short, the void keyword, the void pointer, the CPU or the compiler doesn't understand how many bytes to go read, and because of that, dereferencing a void pointer is forbidden. It's not allowed. And again, remember, typecasting is one way in which void pointers become useful.